So today we're going to start section P.1, which is real numbers and their properties. And I'm going to start with a visual imagery that I think can help if you have any difficulty sort of thinking about how to categorize numbers. So this is the screen, and it should be on your paper with all these boxes, yes? Wonderful. So we're going to actually start in the very tiny little box in the middle and talk about that box first. So the first numbers that you count with, or that you learn when you're a child, is what are called counting numbers. More accurately, they're actually called natural numbers. Sometimes you'll see them abbreviated, a math abbreviation for it. Looks like this capital N, or even sometimes it'll have two lines on the left-hand side. So if you see this anywhere, like maybe in your textbook, or sometimes it'll just bolden the left-hand side, it's talking about the natural numbers. And these are your counting numbers, right? So 1, 2, 3, and so forth. And honestly, you get by with those for a pretty good amount of time. You might introduce some other concepts related to that, but those are the basic concepts that you use in terms of arithmetic, right? People are learning to add these numbers together. That's usually where kids start. And then at some point along the way, when you're doing a subtraction at least by then, you've recognized that there's a need for the number 0. And the number 0 is not one of the numbers that's in that little box, because if you ask a child to start counting, they're not going to say 0, 1, 2, 3, right? They're not. That's not a counting number. So if we include the number 0, we have what we call whole numbers. So everything inside this box where I'm writing whole numbers is a whole number. So all of these numbers, 1, 2, 3, are whole numbers. So that's why these boxes are sort of nested, is because they are whole numbers too. But we have additionally the number 0. So we have 0 and 1, 2, 3, and so on. So we're growing our definition of what numbers are. And not necessarily next curriculum-wise, but at some point, there's an expansion of this idea, and it usually happens around 5th or 6th grade, depending on curriculum, and you have a need for negative numbers, right? All the same numbers I have up here, but they're negatives as well. And when we expand our view in that way, we have what are called integers. So integers, again, include all these numbers. So the number 2 is a natural number and a whole number, and it's an integer, right? Because it's nested inside these boxes. But it also includes the negatives. So often we see them listed like this, and I'll start -3, -2, -1, 0, 1, 2, 3, and so on. These are integers. And the last expansion in this left-hand side of this overall box are where we get things like fractions and decimals, okay? Those actually have a more compact name. They're called rational numbers. Rational numbers are called that because rational has the root word ratio. Okay, so ratio, think fraction, okay? And if you remember, decimals can be changed into fractions. So rational numbers are any numbers that can be written as a ratio. So we're looking at things like fractions. I won't make a list because it becomes impossible to do so at that point. Decimals. That's what we're looking at. And it's both positives and negatives. And it has to be both positives and negatives, right? Because the integers themselves are a compacted, like they're included inside that, right? They're contained. Also, if you think about that, so all of these numbers I've already listed actually on the board are in fact rational numbers. They can be written as a ratio. So for example, the number 3, if I wanted to write that as a ratio, it's 3/1, right? That's the ratio. So you can always take a whole number and turn it into a ratio, hence that's why we would call them a rational number as well. These are not all the numbers that there are, although they are the majority of the numbers we're going to be working with. Not all, but the majority. But somewhere along the way, somebody introduced something called square roots to you. You all know what I'm talking about, right? And there's some numbers that are fabulous. Square root of 4. Yay, it's 2. That's a whole number. But there's some numbers that are not so fabulous. Square root of 3. It doesn't have a closed form in decimals or fractions. It just doesn't. And so those numbers are called irrational. So, I didn't tell you over here. I'm sorry, I got sidetracked. Whole numbers, you'll see abbreviated with a W. again, sometimes bolded on the left. Integers, oddly enough, is not I, it's actually the letter Z. I don't know what the word is because I should probably look it up, but it's actually the Latin word for integers, starts with a Z, I believe, so they use Z. And then your rational numbers are actually not R either, they are Q, and the reason they're Q is the Q is for the word quotient, quotient like ratio. And the reason we don't use R is because this whole thing is the real number system, and that's R. So we use R for real numbers, we use Q for rational numbers. And then over here, irrational, your book uses the letter I. Not all books do that, but just so that you're familiar, if you see it in there, that's what they're going to use. And again, these are things, like I said, squared 3. So your radicals that you can't simplify, right, into a whole number form, that would be included, or into an integer or a rational number form, would be over here. But you also have a couple others like pi. So somewhere in middle school you encountered pi in a geometry class or something. And you also have e, which you may have encountered in high school, maybe Algebra 2. And if you haven't encountered E, don't worry about it. We'll get there when we need it. We don't need it substantially, but there are numbers outside of this worldview, too. They're called imaginary, not because they don't exist. That's not what I mean. It's not like an imaginary friend, okay? But we will get to those toward the end of Chapter P, which is the chapter we're going to be in for the next couple weeks. And we'll talk about those when we get there, okay? But these are where we're starting right now, the real number system. There are lots of properties of real numbers. Some of them you're super familiar with. Some of them you're less familiar with, at least in terms of what you call them. You're probably familiar with the fact that you can do these things to them, but maybe not with what you call them. So the first example here is actually an example of the distributive property. So you have the ability, this is the one people tend to remember, to sort of distribute, right, over the parentheses. So you can take that negative 3 and you can multiply it by x, and you can take that negative 3 and you can multiply it by negative 4. So it looks like that, right? So that negative 3, I'll put that negative 3 in parentheses just for fun, is being multiplied in each case by the value. You can simplify it too, right? That this would then be negative 3x plus 12. That's fine, okay? But that's a property. It's called a distributive property. It incorporates both addition and subtraction with multiplication in a way that allows you to simplify. So this is distributive property. Another property on number 2 is called the commutative property. And you know this to be true with multiplication and addition. It is actually not true with division or subtraction. But the order doesn't matter, right? 5 plus 2 is the same as 2 plus 5. 5 times 2 is the same as 2 times 5. But that doesn't work with subtraction. 5 minus 2 is not the same as 2 minus 5, nor is 5 divided by 2 the same as 2 divided by 5. So it only works with multiplication and addition, and you probably don't even think about it when you do it because it's so ingrained with the facts that you learned back in first and third-ish grades for your multiplication and your addition. But it does have a name, and it's called the commutative property. So if you think about commutative, you can think about the fact that it's changing places, right? Like when I commute from home to work, I change places, okay? Number 3 is an example of what's called the associative property. It's another one where we just do it and we don't think about it. So we can actually regroup multiplication, and we can also regroup addition. So again, this applies to multiplication and addition only. It doesn't work with subtraction or division. So instead of grouping the 4 and the y together, I can group the 5 and the 4 together because multiplication is the only operation here, right? And I then know that this is 20y. Now, you probably don't even do that, right? You probably just say, oh, look, 5 times 4y is 20y. I mean, you do it without even thinking because we do it so much. But that's called the associative property. Associative property does not mean it has parentheses, although it will often have parentheses. There are sometimes parentheses present, and they are not the associative property. So be careful to see, is it really a regrouping of things going on? And again, you can remember that this is associative because associative means how you're grouped with people, right? Or how you're grouped with things, how you're grouping things, what you are associating together. So that's what's happening on number 3. The last 2 are actually properties of absolute values. So I suspect that you remember that when you take an absolute value of a positive and a negative number, the signs all become positive, right? So whether it's negative, like on number 4, or it's positive on number 5, these are absolute value properties. That's not right. And we'll talk a lot more about absolute value properties and how they actually work later. But one of the things to remember about absolute value properties is it's not really just a matter of like changing a sign. That's not what's happening. And if you think about it in that way, it's probably going to cause you problems when we eventually have equations and inequalities that deal with absolute values. What they are actually doing is they're measuring a distance. It's the distance back to 0. So on a number line, if I have a number line here, and here's 0, here's the number 3/4, and here's the number -3/4. What it's actually measuring is the distance in between. So this distance, I need that to be a thinner one. Let's go with that. Still too thick. This distance, grief. Right there is 3/4, and this distance is 3/4. One of them simply is to the right of it, and the other's to the left. So that's what absolute values are really doing, is they're measuring distance. So along that line, when we're taking a look at the distance between numbers on a number line, A and B, for example, oftentimes what we think of as measuring the distance is I take the bigger number minus the smaller number. And you can certainly do that. There's nothing wrong with that approach. But more generally speaking, what it actually is that it's the absolute value of the subtraction in either order. So we'll do an example here on number 6 where we think about it like this, with this absolute value notation, instead of bigger minus smaller, because negative numbers start to look a little bit funny when you think of bigger minus smaller. -3 is actually bigger than -14, but it sort of feels funny to think about it that way too. So if you're thinking about it that way, it's okay, but you can also, if you do it in the wrong order, be okay with it because it really doesn't matter. So just for fun, we're going to do it in the opposite order so you can see what I mean. If I did -14 minus -3, okay, so you'll see I put a subtraction sign between them. That's coming from the subtraction sign right here. Right? So that's the subtraction, but the numbers themselves are -14 and -3 in either order. It doesn't matter at all, okay? But when you have that double negative, of course, what is the opposite of a negative number? A positive number. So the opposite of -3 right here, these double negatives, become a positive for a 3. And now you're to the point of taking -14 and +3. What is -14 and +3? Yeah, it's actually -11. But again, we're talking about distance. And so what is the absolute value of -11? Well, it's 11. Now, if you happen to have done the subtraction in the other order, that is, you put the -3 first and the -14 last, instead of getting -11 inside the absolute values, you'd get +11, and then you'd be good to go, and it would be irrelevant that the absolute value is even there. But either way, it will give you the same 11. Okay, everybody good so far? Lovely. Okay, exponents. Reminder about exponents. When n is a positive integer and we have a to the n power, we will be multiplying a together n times. Exponents themselves don't usually confuse us, but sometimes the notation between 7 and 8 will confuse students. You notice the difference is the parentheses, right? So what difference does it make? Well, it actually makes a lot of difference sometimes. So what you should notice is that wherever the exponent is, whatever's next to it is what's being done that many times. So this -4 or -3 is -3 4 times. And when you do that, you actually have 4 negatives, which means your answer will be what? Positive, right? So you have to take note of the fact that 2 negatives make a positive, so these 2 will end up being positive, these 2 will end up being positive, so it's a positive answer overall. So I am going to have a positive. You don't have to write the plus down, but I'm going to do it just now for as a standout. And then 3 times 3 times 3, 4 threes, right? What is 3 times 3 times 3 times 3? That's addition. We want to multiply. 81. Yeah, it's 81. And if the numbers get too big, I mean, you've got a calculator. There's nothing wrong with grabbing your calculator and doing that. Okay? So yeah, the answer is 81. But that's not what number 8 is asking you to do. This power 4 on number 8 is only on the 3. Okay? So you don't have to like it, but that's how we have to have a mathematical standard for how we both interpret it. And so the interpretation that is commonly accepted and used in mathematical world, the whole world, is that this 4 applies only to the 3 because it lacks parentheses around the negative, including it with the 3. So what that actually says instead is that I have a negative, and then I have 3 times 3 times 3 times 3, which means while I still have an 81, this time it's negative 81. So those parentheses matter. And if you're not careful, your calculator won't help you either, because your calculator has probably got its own operating system of how it's going to deal with the parentheses, and it may or may not be the way that you're thinking it happens to do it. So just be careful about that. All right. All right, next topic is order of operations. Order of operations is not a difficult topic, but it trips people up all the time. I had he went through Calc 1 and Calc 2 with me, and he's in med school now, and he saw something, I think it was probably on a Facebook meme or something in whatever social media network he was in, and he wanted to confirm with me that he remembered something right, because he had friends all over the board saying, no, it's this, no, it's this. And he's had a lot of math. Like, this is not a hard topic, but people mess this up all the time. The whole thing that happens with order of operations is you work from the inside out. It's always from the inside out. So whatever's in the innermost piece, that's what you do first. So on this one, the innermost piece is the 2 times 3. So you're going to multiply 2 times 3 before you do anything else. So 2 times 3, of course, is 6. Now, as I work, I'm going to write all the other pieces down and not do anything with them. I'm just going to rewrite them. So 2 times 3, 6. And again, I'm working from the inside out. You don't really need the 6 in parentheses now because there's nothing happening to it. To do it, there's no grouping needed. But now I have 4 minus 6 inside the absolute values. And 4 minus 6 is, 4 minus 6 is negative 2. Okay? It's really tempting to skip steps, but you might miss signs if you do, so just be a little bit careful as you choose what steps to show and not show. Show me some work anyway, okay? But then I've got the absolute value of negative 2. Here's where a lot of students will make a mistake. They see a negative here, they see a negative here, and they think that they're going to operate like they do with parentheses. And I don't think it's intentional, it's just we're moving quickly, and so we move through it, and we do the same thing we did basically on that last problem where we multiply the 2 negatives. But we don't. We have to do the absolute value part first. So what's the absolute value of negative 2? It's 2. So I have 5, I have the subtraction sign, and then the absolute value of negative 2 is 2. And then my last step, of course, is 5 minus 2 to give me 3. So we're working from the inside out. Now, not all order of operations problems have absolute values. Here's a couple more examples. The first one especially feels kind of like that last one that we did, just doesn't have absolute values. So as we're looking at this problem, the innermost thing is the parentheses. But within the parentheses, we have to remember that the order of operations over here have to be applied. So I mentioned working from the inside out. But you probably also remember, I'll write it over on this screen since I've got some space, this acronym. There are other acronyms that are being used these days as well, but this is one of the ones that's mentioned often, is PEMDAS. It tells you that first you're supposed to do parentheses first. So that's kind of why we did the 2 times 3 first when we talk about inside out. Exponents are next if they're present. They aren't always present, but if they are next. This is actually a misnomer, the M and the D. There's not an order here. You can multiply and then you can divide, or you can divide and then you can multiply, but what you actually have to do is work from left to right. So these are interchangeable with one another. And you move from left to right. And the same is true for the A and the S, the addition and subtraction, and they interchange too. And you move from left to right. So thinking about that overlaid on top of this inside first on number 10, The parentheses is where we're going to start. But within the parentheses, there's two operations. There's subtraction and there's multiplication. And there is a correct order. And if you do it without that correct order, you will end up at the wrong destination. You just will. So the correct place to start would be what? The subtraction or the multiplication? Yeah, the multiplication. So the first thing that we're going to actually do is the 2 times 8. So I've got the negative 2 out the front, and I've got the negative 3. By the way, you can't subtract the negative 2 and the negative 3. It's tempting. I see students do it all the time, but you can't. So just hold tight. Work from the inside out. We'll get there eventually. And I have 5 minus 16. Still inside out. So now I'm still in the parentheses. The parentheses are still there because I haven't dealt with them and simplified everything inside. So 5 minus 16 would be, negative 11. I don't have to worry on this one about absolute values since they aren't present. So I do, in fact, have multiplication still present here. Now, I left the parentheses around the negative 11, not because I need it as a grouping symbol, but because sometimes it's nice to have it around negatives to remind ourselves there's multiplication going on. So these two right here are actually being multiplied because of those parentheses. It's understood notation. So I still have that negative 2 in front, but multiplication needs to happen before the subtraction. So that negative 3 times that negative 11 is what's next, which gives me a positive 33. And then finally, the negative 2 plus the 33 would be 31. Number 11 is interesting because while we see parentheses, we can't actually do anything inside of them to simplify them. I can't combine the 4 and the negative 2x. I can't combine the x and the negative 5. That's not a possibility. So what I'm ending up having to do then is go back to my properties of real numbers that we talked about before. And what operation am I going to be using, or what property? The distributive property, precisely. So I'm going to distribute across here. Be careful when you get to the second distribution that you are distributing a negative 2, not just the 2. So the 5 times 4 is 20. The 5 times negative 2x is negative 10x. And then I have negative 2 times x, so negative 2x, and negative 2 times negative 5 for a positive 10. Okay, so I'm going to group things together that are alike. And if I move from left to right, because it's all addition and subtraction here, right? So over here I just said addition and subtraction are interchangeable. Doesn't matter which one happens first. We're just going to move from left to right and group things together. I don't really need to regroup them visually. I can probably just mark them or even like focus on them as I'm doing them. I have a positive 20 and I have a positive 10. So that gives me 30. And then I have a negative 10x and a negative 2x, which gives me negative 12x. Any questions on that? Every now and then I have students who do a couple things that I need to make you aware of really quick. If you're one of these people who calls this a 0, please don't do that. That's a notation for something else we're going to be using later. I know it's really tempting, but don't put the crosses through your zeros. And other times I will have students who like to put equals at the end of everything like that. They keep putting equal signs. Also not a good plan because once we start working with equations and equal signs are actually a part of that, it makes things really confusing. So don't insert equal signs if they're not already there. If it really bothers you, you're welcome to put like an arrow. Sometimes I'll have students do arrows because it says, and then I do this, and then I do this. You could do that. All right, I think I have one more thing on this note set. Does that look right to you? Fabulous. Our last thing is evaluation. So we have an expression here. It's a squared minus bc over a, and they give you values. So this really isn't a whole lot different than the things we did over here, except that the things aren't they aren't put into there to begin with. So we have this sort of step that we have to do in advance. So when I have that a squared and the a is negative 2, I put a negative 2. But since a is negative 2, all of negative 2 is squared. And again, we talked about why that mattered, right? And it matters to write it down properly so that just in case you did grab your calculator to check something, if you leave it off, your calculator is not going to do the order of operations right either. Okay, so the parentheses need to be there. Subtract, my b value is negative 3. So again, I kind of like parentheses to separate negatives out usually, so I will put them in. If you don't want to do it that way, it's okay, but it might look a little bit more confusing to read. The last one is that c is 0, so I'll go ahead and put that in parentheses as well. And then it's all divided by a, which is negative 2. So there's parentheses here, but there's not parentheses in the sense of order of operations because there's no condensing within them to be done. Does everybody see that? This isn't like the one over here like on number 10. I don't have an operation happening within a single set of parentheses. But I do have exponents, which I haven't had in the previous problems. So parentheses first, exponents second. So my exponents is actually second. So I have -2 squared. And what would -2 squared be? 4, right? Positive 4 because I have -2 times -2. So I have the 4 here. So you notice I put an equal sign here. I just did that because I did it on the right-hand side as opposed to underneath. If you don't want to do that, you can put an arrow like I mentioned before, or we can write it underneath. So I'll put a 4 here. And then this is a subtraction sign, but I end up having -3 times 0. So that's 0. I don't have to really do a whole lot on that one. And then I'm still dividing by -2. So 4 minus 0 is 4. 4 divided by -2 then is -2. Okay, so a couple of things. Since this is your first assignment, we are finished with this section, and we'll stop here today. But a couple of things to keep in mind as you're doing your homework. Please label things clearly. Please write neatly, because I actually have a grader who will be doing some of the grading as well throughout the course. We want to make sure that we give you every opportunity to get the points you can. Like we want that, but you got to help us out too. Make sure that you are somehow indicating where your final answer is and how you got there. Work all over the page is really unhelpful for trying to figure out where you were and how you got there. It also helps us to identify where mistakes are made if there's a mistake made along the way. And I think that might be about it. If you have any questions on something, let me know. And we will pick up with section P2, which you've already got printed, on Tuesday. Have a great week, guys.